Here's a couple examples of how we use our power rule for some basic differentiation. So it's a couple that will help on this 2B assignment. So first of all, to use the power rule, well, what is the power rule? Let's remind ourselves of that. We know the derivative of x to the n is in x to the n minus 1. So the power drops down, and we subtract 1 to get a new power there. All right. Well, what do we do here? We know we can look at each of these parts individual, but it's different when we have a fraction or a quotient like this. But we can rearrange this first so that all we have is a bunch of powers being added. So what we want to do is we want to divide each of these by x cubed. So let's divide the first term here. We're going to rewrite here. X to the fourth divided by x cubed would be x to the first, right? And then we have x cubed divided by x cubed, and that's just 1. And then we have 7x, so x to the first, that is, divided by x to the third. We subtract exponents, and we get x to the negative 2. 1 minus 3 is negative 2. Now we're ready to use the power rule. All right, so we can find the derivative, f prime of x. And we got a power of 1 here. That 1 times 5 is 5. And that would leave us with x to the 0, which we don't need. Then we have a constant. Derivative constant goes away. And then we have power here. We can multiply this negative 2 times negative 7. That's positive 14. Subtract 1 from 2. We get negative 3. And last thing we'd like to do, it's good to go ahead and make these into positive exponents. So let's rewrite as 5 plus 14. And remember what it's a negative exponent. It goes downstairs, down to the denominator, becomes positive, x to the third. Okay? There you have it. All right, one more situation here. We have a problem here. We want to find the equation of the tangent line of the graph here of f at the given point. And then we'll check it out to see, to graph the function and its tangent line at that point. And we'll use the derivative feature of the graphing utility to confirm our results. Okay. Let's start by taking the derivative here. Well, actually, before we do that, notice this. Here we have a point. This is just saying when x is 1, y is 2. Let's confirm that. 4 times 1 cubed minus 5 times 1 plus 3. So that's going to be 4 minus 5 plus 3, which is 2. All right? So that is our point 1, 2. So let's go ahead and find the derivative. Y prime, use the power rule. 3 times 4 is 12. X squared minus 1 times 5 is 5, because the power is 1. And then the power goes, 1 minus 1 is 0, so the x is gone. And the derivative of a constant is 0. So there's our derivative. Okay? Let's try that again. All right, so our derivative there. And now we want to find out what is the derivative when x equals 1. And the way we write that is like this. So when x equals 1, we're going to say the derivative of y, the derivative of y with respect to x when x equals 1. So this bar here, we say evaluated when x equals 1. Okay, is what we're doing here. So we can write that as, another way to write that is the derivative of 4x cubed minus 5x plus 3 evaluated when x equals 1. Okay, well that just means we're going to take the 12 times 1 squared minus 5. And that's 12 minus 5, which is 7. Okay, so we know that y prime at 1 is 7. So we have a point, and we've got a slope. This is our slope. So let's write an equation in point-slope form here. So we have y minus y1 equals m times x minus x1. Okay, then we want to probably put this into our calculator, so we're going to distribute and put this in slope-intercept form. Add 2, add 2. So y equals 7x minus 5. All right? So this is our tangent line. So to go to our calculator, in this program, I can't go to my calculator, so I'm going to put some screenshots up here. So if we start by going and graphing our function, we'll get this function here. F of x equals 4x cubed minus 5x plus 3. Then if we go enter our equation 7x minus 5 into the F2, we'll see that yes, indeed, that is the slope of the tangent line. That is the tangent line. That is the equation of the tangent line, I should say. Okay? And it meets right there at 1, 2. Then, if we want to check the derivative, we can go to our menu and calculus. So hit menu, calculus. And we want to find a derivative at a point. Not just a derivative, but we're doing derivative at a point. And when you select that, it'll give you this thing here. And then you can fill in our expression there, our function. And notice here, there's that evaluated at x equals 1. That's what that little bar means. And the answer it'll give you is 7. So yes, the derivative when x equals 1 is 7. And we verified there at the graph that, yes, indeed, that was the right equation. All right, well, there's some good examples to help. So thanks a lot. Keep working at it. You got it.